For this 8th exercise, this is more simple. It is just substitution. We're just going to use those trigonometric identities, those in here. Okay, it's straightforward. Okay, we just have to remember, okay, those the secant, inverse of cosine, the cosecant, inverse of sine, the cotangent, and so on. Okay, and the basic ones, the sum and difference. And just remember, okay, when you're dealing with the cosine, it's plus plus, minus minus, no problems. When it's cosine, it is reverse. Okay, if it is cosine of x plus y, we're going to have a, if it is plus, we are going to get minus in here. It is reverse. Okay, and the tangent, it is also reverse down here, plus plus minus. Okay, just be attentive to that. The double angle, okay, no problems. Sometimes we're going to use this relation, okay, sometimes we're going to use this other relation, because sometimes we're not interested about inserting the sine, and we just want the cosine. We just see which one it is best, or maybe we just want to get rid of the cosine and we just get the sine. Just straightforward, okay, there is not much to say. And what about those half angles identities? They just come from those identities up here. We just have to isolate. Okay, for instance, let's take cosine of 2x. It is cosine squared of x minus 1. Just take the minus 1, drop to the sides. It is going to be cosine of 2x plus 1 if you just divide by 2. Okay, and just square root what I just said. It is this. Okay, so this equation in here becomes this one. You just have to rearrange things, but those you don't have to memorize those. If you just know those are straightforward. They come from this one. And let's get back to our problem. We have sine of x, it is 1/5, and cosine of x, it is negative 3/5. Just one small detail in here. I'm going to this is y, okay? Okay, ready. It is the sine of x and the cosine of y. We have two angles, okay? Now, what are we going to do? Well, we are going to use this formula. Cosine of x plus y, it is cosine of x times cosine of y. Okay, remember the cosine, it is the opposite. If we have plus, we're going to have a minus in here. Well, now let's just put the sine. Sine of x times the sine of y. Okay, now for that we can understand that we need to know the sine of cosine of both angles. How can you do this? The best way to do this, in my opinion, it is just this. Let's just build a triangle. This is the fastest way to understand what is going on. Let's build a triangle for one angle, okay, and another triangle for the other one. So this is going to be x and this is going to be y. And what is going to be like? Let's take maybe this color in here, or maybe this one. Okay, now they say that the sine of x, it is 1/5. What is sine? It is this leg, right, over the hypotenuse. So it is 1/5, right? What about the cosine of y? For now, I'm going to ignore the signal, okay? Because signals, plus or minus, they have no sense when you are working with triangles. Everything is positive. Now, the cosine of y, it is going to be 3/5, okay? Now, using Pythagoras, 5 squared equals 1 squared plus this 1 squared. We can, it's not difficult to see that this is going to be square root of 24. Square 24, square root of 24. You see, if we square the square root of 24, we just get 24 plus 1, 25. Good. Now, this is again Pythagoras in here. This is going to be 25. This is going to be 9. So what is left for 25? Just 16. Okay? Square root of 16, it is just 4. Well, this is what I call the magical triangle, right? 3, 4, 5. This is very easy. The good thing about this is that once we know this, we have, for x, we have the sine of x, it is 1/5. We have the cosine of x, it is square root of 24 over 5. And we all have the tangent of x, which is 1 over square root of 24. We have everything here and everything here. Well, if you just wanted to use sine squared plus cosine squared equals 1, it goes the same way. I just prefer to use like here. It's, for me, it's simpler, but it doesn't matter. Each one has its own way to resolve. And that's the beauty about math, okay? Different roots get to the same place. Okay, sometimes different roots get to different places, but in this case, it's something went wrong, right? Different roots should lead to the same place. Now we just have to plug in the numbers, right? Everything is here. Equals cosine of x. The cosine of x is square root of 24 divided by 5. Cosine of y, it is 3/5. Okay. Then I'm going to put the signals, okay, in a second. I'm just using the numbers first, the figures. It is 3/5 minus, we have 2 again. What is the sine of x? The sine, it is 1/5. And what is the sine of y? It is 4/5. Not yet, okay? We have to be careful about the signals. Why? Well, remember, let's use this one. Remember that the sine and cosine, they come from the trigonometric circumference. Remember that the trigonometric circumference here is the cosine, here is the sine, this is minus 1, 1, 1, this is minus 1. Remember this? Okay. And why is he telling us that in which quadrant? Okay, remember, this is going to be the first quadrant, second, third, fourth. Okay. Now, why is he telling us? Because look, when this is an angle, the sine of x, it is 1/5. The sine of x, it is 1/5. Well, 1/5, it's, if this is 1, let's take black, sorry, maybe 1/5 should be something like this, okay? This should be 1/5. Okay, the sine, okay, sine 1/5. Well, look, 1/5 could be this angle in here, it could be this angle, or we can also have this angle in here, and this angle is going to go all the way from here up to here. Can you see? And this one is just this one. So we, when the sine is 1/5, we can have two angles, one in the first quadrant and the other one in the second quadrant. Therefore, he must tell us x, it is in the second quadrant. So it is this big angle in here. okay? It is not this one, okay? So I'm not going to say that, but x, it is in here, okay? It is this big one. So we know that x from this, let's just make our notes in here. We know that x, it is bigger. Let's put it like this. It is bigger than 90 degrees, okay? And also is smaller than 180 degrees because it is in this quadrant in here. What about the cosine of y? Let's see what happens to y. The cosine of y, it is negative 3/5. Well, the cosine negative, I'm not going to write over this because it's going to be a mess, but what is negative for the cosine? It is on this. Let me see if I can do something like this. This is the negative side of the cosine, okay? All these green parts, it is negative for the cosine. And so the cosine, when it's negative, it can stay on the second or the third, okay? We have two possible angles, but we know that y, it is on the third quadrant. So the y, it is in here. So our x, it is in here, and our y, it is in here. So y must be bigger than 180 degrees and smaller than 270 degrees. Okay? Just to understand why is he telling us this. Now that you are going to apply these signals, and in my opinion, the beauty of the exercise, it is this part that comes now, because those numbers, we just use it from the triangle, okay? But they can be pluses or minus. Now, let's see carefully. Cosine, the magnitude, it is this, okay? The magnitudes are all those in here, but let's see now the actual value. Cosine of x, x, it is in here, right? So the cosine, it is always going to be negative. So let's put a negative in here. Again, the cosine of y, also negative. Because look, let me repeat again, because this is very important. When you just find out the sine and cosine is used in triangle, we are ignoring the possibility that it can be plus or minus, because everything is squared. Remember, 5 squared, 1 squared, square root of 24 squared. We square everything. Therefore, if it is plus or minus, it doesn't matter in here. And if it matters, it is going to disappear. But since it is an angle, the angle, when you're using this expression, angles can be in very different parts of the circumference. Therefore, we have to account for the signals. This is the most important part of this exercise. The rest is just copy and paste, okay? Just remember, memorization. This is very easy. This part, it is the best one. Now, sine of x. The sine of x, it is positive. Good. I'm going to put to make sure that I pass it from here. Sine of y. Y, it is down here. This sine, okay? Every time this sine, those signs are positive, and those signs are negative. So the sine of y is going to be negative because the y, it is down, okay, here. Okay, now it is just multiplication, okay, and just get the answer. And the answer, it is just this, okay. Now this other one, this is going to be the same because the triangles are already here, everything is set. When you just take the identity, we are going to see that sine of x minus y, it is just the sine of x times cosine of y, and this is the same signal, okay, minus now the sine of y plus the cosine of x. We just switch, okay, we just substitute, okay, everything, sine of x. Well, I'm just going to use this one, okay, straight this one, because I don't have to think everything again. So the sine of x, it is going to be this 1/5 plus, right? I'm going to put the plus to know that I already passed it through this phase. Cosine of y, it is going to be negative 3/5. Okay, I think it's too small, right? I'm trying to make a little bit bigger. Minus sine of y, it is minus 4/5 multiplied by the cosine of x. Cosine of x, it is negative square root of 24/5. Again, okay, no secret in here. And this is the answer, okay? This part, it is not, I mean, it is important because it is the answer, but the most important part was this discussion we did in here. The rest, it is just copy and paste. For this next one, okay, I'm not going to do it, okay, because it is the same in here. I'm just going to make this the first step, but remember that the sign minus minus plus plus. So I'm not going to do, and I'm going to pause and then start over with the answer because it is just copy and paste, okay? Now for the tangent, well, let's get to that trig identity again. I think it's worth to just put another time. And here we're going to see the tangent of x plus y. Oh, just remember, okay, sine plus plus, sine cosine, cosine sine, and the cosine, it is cosine and sine, but plus we just change the signal in here. For the tangent, it is just x plus y is going to be the tangent of x plus the tangent of y divided by 1 minus, okay, it is reverse, the tangent of x times the tangent of y. And let's do this in here. So let's copy the formula, and this is going to be tangent of x plus tangent of y, 1 minus, remember, 1 minus, multiply them, tangent of x times tangent of y, okay? And we're going to do the same process, okay? First, I'm going just to put the numbers, and then we're going to see the signals. What is up here? X. What is the tangent of x? Oh, and just one thing. For now, I'm going to make a little note in here. Let's discuss a little bit what happens to the tangent. Let's suppose we have this. I'll try to make as perfect as possible. We know that here is a cosine. We also know that this is the sine. And what is the tangent? My ruler should be in here. I'm going to put in black, okay, because all the axes are in black. This is going to be the tangent. Okay, and this is the tangent line. That's where we measure the tangent. It goes like this, up. For instance, let's take any ordinary angle. Let's suppose we just want to find out this angle in here. And this angle, it is alpha. What is going to be angle alpha? Well, the sine, to read the sine of alpha, once we know this angle, when the angle touches the circumference, we just measure the cosine, and this is going to be the cosine of alpha. If you just want to find out the sine of alpha, you just have to transfer to here, and this is going to be the sine of alpha. Remember that this is plus 1, this is 1, this is minus 1, minus 1, okay? Because the definition of the trigonometric circumference, it is a circle with radius 1, okay? This is the definition. And what about the tangent? What do you do to get the tangent? Let's color the use this one. Yeah, use this color here. Well, we just prolong, okay? And this is going to be the tangent of alpha. Simple as that. But why did I write this? Because I wanted to discuss something. Let's discuss that. This is going to be our angle, okay? Let's just discuss the tangent, because the tangent, it is what it needs to be discussed. 0, I'm just going to say, okay, this is the origin, and the tangent 0, and goes. When it's 45, what is the tangent of 45? It is just 1, isn't it? It is going to be precisely in here. This is the tangent of 45. This is basically 45 degrees, right? Because this angle is a little bit higher than 45 degrees. How do I know that? Because if I just make, this is going to be 1, right? This point in the tangent, it is going to be 1. Tangent of 1, I mean not tangent, but the arc which tangent it is 1 is 45 degrees. Therefore, this must be a little bit over 45, but it doesn't matter. And we just go increasing the tangent. Tangent of 60, and then we just go increasing. Can you see the tangent of maybe 80 degrees? This is 80 degrees, right? They are going to meet each other. I mean, the tangent axis and this, they are going to meet way over there. And imagine this. They are going to meet maybe 100 meters ahead. And what about this? Maybe in the end of the planet they are going to meet, okay? Sooner or later they will, because it's not still 9 degrees. And when it's 9 degrees, well, when it's 9 degrees, they will never meet, because now they're going to be parallel. This line is never going to meet this line here. That's why the tangent of 9 degrees doesn't exist. And the tangent of angle that gets closer and closer to 90 degrees is going to tend to infinity. And now look what happens. Okay, so we don't have the tangent of 9 degrees. And as soon as you just make this bump like this, look. A second before we were at plus infinity, right? And now, because we just moved a little bit to this side, now it's going to be negative infinity. Why? Because, and that is the angle that I want to discuss now with you. Let's discuss this gray angle in here. This angle. Let's discuss another angle, and this is going to be okay. Let's call it beta, this angle. Again, this is going to be the cosine of beta, the sine of beta. And what about the tangent of beta? We just have to prolong it. In here. This is going to be the tangent of beta, this length in here, okay? And that is what I wanted to discuss. So whenever we go from 0, it goes like crazy, the tangent, okay? From 0 to 90, we have positive tangents, okay? We are just increasing. Now, from 90 degrees to 180, this is going to bring, look, this is the continuation, okay? This is a tangent in here, can you see? This portion in here. So from 90 up to, and again, this length, it is a tangent. So from 90 to 180, we get negative. Again, when you go from 180 to 270, it is negative. And again, when you go from 270, okay, now don't need this one, 270 to 360, we get negative again. So the tangent goes crazy, okay? In the first quadrant, it is positive. Here, let's write down. Yeah, it's in here. So in this quadrant in here, the tangent, it is positive. In here, the tangent, it is going to be negative. In this quadrant, in the third one, the tangent is going to be positive, right? Why? Because this is the angle, and just make a projection over there. It is going to land in the positive side of the tangent. And again, this is going to be negative. You see? It goes like crazy, okay? It changes signal like crazy. And that's why I just wanted to make sure that we understand this. What I mean is the sine and cosine, they change the angle just twice, okay? But the tangent changes the angle 4 times, okay? Every 90 degrees we have a different angle, and it goes from plus infinity to minus infinity. It's very crazy. Let's check now what is going on in here. The blue pen, it is in here. X is here. Remember, if the angle is in here, you're going to project this in here. The tangent, it is going to be negative, okay? This is the negative side of the tangent. But before that, let's just plug in the numbers. Then we just see the signals, one thing at a time. Tangent of x, we are here. The tangent is 1 over square root of 24, right? This is the tangent of x. Plus, what is the tangent of y? It is 4/3. Signal we're going to see in a minute. 1 minus this multiplied by this. Tangent of x, we have seen, it is 1 over square root of 24, and tangent of y, it is just 4/3. Again, the red pen, x is going to yield a negative tangent, right? So this is going to be negative, and this is going to be negative, okay? Now, the tangent of y is in here, right? It's something along here, the angle. If you just make a projection to the tangent axis, you're going to get a positive. So I'm going to write positive just to make sure that I pass it through this. Well, now there is no more secrets, okay? I'm just going to pause and get back with the answer, okay? You don't have to follow this. And now, okay, so this is the answer. Okay, crazy number like this, but this is the answer. Now, this is probably the most beautiful question in here. What is the quadrant for the angle x plus y? Now, for that you need some insights, okay? Of course, we have no idea what this is, okay? You don't have to be. Let's look in here. We are going to need 2 informations in here. We are going to use this information and the tangent. Let's just sum, okay? If I just add both of them, we know that x, it is in here. We know that y, it is in here. Therefore, if we just add x plus y, what is the interval they are going to be? Well, I just have to add. I'm going to put the answer, okay, straight, because it's going to be worse that 207 degrees. And now I'm just going to say it, okay? 270, it is adding those two in here, okay? And again, if we just add those two, we just have 450 degrees. 400, okay, and let's translate. What is this? Into something meaningful. Okay, and this is 270 degrees. Okay, we have to know 0, 90, 180, 270, or 360. 450 up to here it is 360. 450 it is going to be right in here. So our angle plus x plus y, it could be, I'm not saying it is, I'm just saying that it could be in the first quadrant or in the second one, just looking at this information. Now we have another information that is going to be the tangent. No wonder they ask us to give us the tangent. The tangent goes, right? It goes to infinity. This is the tangent. This is the cosine and the sine. Let's look in here. 3/4. This is positive. The denominator also positive. We don't know how much is square root of 24, but at least we know that it's something like what? 5 times 5, 25. 4 times 4, 16. It must be be between 4 and 5. So 4 point something. Either way, it's less than 5. So 32 minus something less than 5, well, the numerator, it is also going to be positive. So we know that the tangent of x plus y, it is absolutely positive. Okay? If we just choose this quadrant in here, we get a negative. Tangent, it is negative. In this portion, tangent, it is positive. Therefore, what quadrant are we in? In the first one. We gotta be in here. Why? This is the angle that we are looking for. And why? Because we know that the tangent, it is positive. We also know that it must be in the first or in the fourth quadrant. So it must be in the first. Okay? Just one note. We could also have done it just instead of using the formula, we could just use just divide the sine divided by the cosine. We could do this because to get tangent of x plus y, we could just divide this one by this one in here. Okay, it would also work. Yes, and I just did the math and it matches. Okay, they are absolutely the same. Okay, I know, of course they are. I'm just using this to check if maybe there is some mistake in any number in here. No, there is no mistake, because if we just divide the sine by the cosine, we just get this. We just did on sideways in here just to check. Those tricks are also very good, because if we divide this one by this one and it's not this one, then something's wrong among the process. And checking your answer, it is always good.